Have you ever asked an AI a question, gotten a really confident answer with a citation, then checked the source and found out it doesn't exist? If so, you're not alone. And it's not because the AI is broken, it's because of something called hallucination. Understanding it is critical if you're going to use these tools in business. A very large percent of professionals surveyed admitted to faking their AI knowledge. They may nod along in meetings, they say, sure, we use AI, but when pressed, they often can't identify when AI is wrong. They don't understand why it's wrong, and that's creating a massive credibility problem for AI adoption. Today, we're going to fix that. We're going to talk about what hallucinations actually are, why they happen, what context windows have to do with all of this, and most importantly, how to protect yourself and your business from AI getting it wrong. So what are hallucinations? Let's start with a clear definition. Hallucination in AI is when a large language model generates output that looks totally confident and polished, but it's factually wrong. It's made up. The model presents it with the same certainty as accurate information. That's the scary part. There's no hesitation. There's no let me double check. There's no I'm not totally sure about this. It just generates text that's incorrect, and it sounds like it knows what it's talking about. Hallucinations show up in four main ways. First, there's factual fabrication, inventing facts, statistics, dates, quotes, or citations that simply don't exist. You ask for a study on remote work productivity, it invents, a study with a specific author who never published that paper. Second, there's entity conflation, mixing up people, places, or events. Saying something like Steve Jobs founded Microsoft or the first iPhone launched in 2005 instead of 2007. Third, there's logical inconsistency. Sometimes AI will contradict itself within the same response, saying an approach is cost effective in one paragraph, then warning that it's expensive in the next. Fourth, there can be false attribution, citing sources that don't exist or misattributing statements. This one is dangerous because a fake citation with a real looking author name and journal title is incredibly convincing if you're not verifying. And here's what makes this so insidious. These models are fluent. They're trained to produce natural sounding text. A wrong answer doesn't look different from a right one until you check. So why hallucination happens? Why does this happen? Reason number one, these tools are statistical pattern matching machines, essentially. This is the big one. Large language models predict the next most probable word in a sequence. They're not searching a database of facts. They're predicting what word comes next based on patterns from millions of documents. They don't actually know that George Washington was the first president of the United States. They know that's the pattern that tends to follow that sequence of words. When the pattern is ambiguous, the model fills in the gap with something that sounds plausible or probable, but it may not be true. Think of it like autocomplete. If you type in, autocomplete pops up, it predicts and jumps over to, the next part of the sentence, not because it knows for sure that's what should follow. It's really just saying what's most likely to follow. Reason two that hallucinations can exist is training data quality. Models learn from massive amounts of internet data, web pages, books, articles, forums. That data contains errors. It contains outdated information, and it contains flat out contradictions. Wikipedia has mistakes. Reddit threads have incorrect information presented as fact. News articles get things wrong. If the training data got something wrong, the model learned that the wrong thing as confidently as it learned the right things. Reason number three for hallucinations is there's not a great grounding mechanism. LLMs do not have a built-in way to verify claims against a real-time source of truth. They can't pause to check a database. They can't call up the journal to verify a citation. They generate based on learned patterns, not facts. This is why models can make up or misstate current events. They literally cannot access the present without using tools, which we'll talk about in other videos. Reason number four is overgeneralization. Models learn broad patterns and apply them everywhere, even when they shouldn't. It knows how academic papers are structured. It knows how legal citations are formatted. So when you ask for a source, it generates something that looks like a real citation. Same format, plausible author, believable journal, except maybe that paper, that article didn't exist. The pattern was right, the fact was wrong. Another reason is prompt ambiguity and helpfulness bias. When you give a vague prompt, or worse, when you confidently ask about something the model doesn't know, it still generates an answer. It's trained to be helpful. Saying I don't know kind of scores 0 when they're testing these things. Generating something plausible, at least, has a chance of being right. So it'll guess. And sometimes those guesses are wrong, even if they're often right. Reason 6, decoder randomness. The parameters used during text generation, like temperature, introduce controlled randomness. Higher temperature means more creative, more varied outputs, but it also increases the likelihood of generating tokens or words that lead to factually unsupported statements. Another reason is knowledge cutoff and temporal drift. Every model has a training cutoff date. You ask about events after that date or about rapidly changing information, and you're in hallucination territory. Again, this is where tools come in and allow it to, for example, search the internet to pull in more relevant information, but that doesn't totally negate hallucinations, of course. And one more cause that ties into our next topic in this video is long or complex context windows. As conversations grow longer, the model can lose track of earlier details and introduce contradictions or fabrications to maintain coherence. So let's talk about context windows, because this is one of the most misunderstood concepts in AI, and it directly connects to hallucinations, and it is a core concept that I believe everybody needs to know to work well and get good results with large language models. The context model is context window is the model's working memory. It's the maximum amount of text or tokens that a model can process in a single request. Everything in your prompt, the question you asked, any documents you attached, the entire conversation history, the system instructions, and the response the model generates, all of it has to fit within this limit. So what's a token? It's roughly about 4 characters or about 3/4 of a word in English. So if you see a model says it has 128,000 tokens as its context window, that's roughly 96,000 words or about a 200-page document. Current models advertise impressive context windows. Some of the more recent frontier models advertise 1 million tokens or even up to 2 million tokens for their context window. That sounds like you can just drop in an entire book and the model will handle it just fine. Here's the problem. Research from numerous authorities has found something called the lost in the middle phenomenon. When researchers tested models on information retrieval across long contexts, they discovered a U-shaped performance curve. If the relevant information was at the beginning of the prompt, accuracy was high. If it was at the end, accuracy was also high. If that same information was buried in the middle, the accuracy dropped materially. And here's the kicker. This happened even on models specifically designed for long context. The model's attention mechanism is biased towards the beginning and the end, not unlike humans, actually. Additionally, the context window can really expand as conversations continue. And this is a concept a lot of people aren't necessarily familiar with. So I started a chat here, and as I go on and it's processing my original prompt, my background and personalization instructions, it responded to me, right? Then the conversation takes another turn. I responded to it again. A lot of people don't actually understand what happens at this point. The large language model itself is not holding a memory of this whole prior conversation. What actually happens when the conversation turns or goes back and forth, and I prompt it again, is that now the large language model is going to process this prior conversation again, fresh. That's how it, quote unquote, remembered what we talked about and built upon it and continued to go back and forth with me. This is really key to understand, because as your conversation takes more turns, more back and forth, the amount of the context window that we are using is building up. It's expanding, and it can expand exponentially, actually. And so many people have experienced this, kind of directly or indirectly, where they had long conversations with AI, and then later in the conversation, they start experiencing things like, it forgot something I said earlier, it misstated a fact I gave it, etc. What may have happened is that the context window may have become overloaded. You have too much that's trying to process within its context window. It cannot handle it. And so it can no longer really accurately recall with great accuracy everything in that conversation. So again, a lot of people don't know this and they keep these indefinite chats going and they're chewing up more and more context window on top of feeding it lots of documents, lots of background, lots of instructions. And look, that can be good at times, but you have to be aware of the context window. So another recent finding from really quite a few sources is that the advertised context window limit, that number that they publish and say it has a million token context window, that may be true in theory, but what they're finding now is that somewhere around using, let's say 50 to 80% of the advertised context window, the quality of the model's outputs starts to drop again materially. That drop was even more significant for older large language models, but even with the most recent frontier models, the drop in quality as you are chewing up a larger percentage of the context window is still very material and worth noting, especially when you're doing critical work in a business context. So let's talk about 10 tips for managing context, because this is so key. Here are 10 things you can do right now to manage context windows effectively and reduce hallucination risk. One is place critical information at the beginning or end of your prompt. Do not bury key details, key constraints, key rules in the middle. Remember that kind of U-shaped curve. The model pays most attention to the start and finish. 2, use explicit formatting markers, begin instructions and end instructions, or numbered sections. It can help draw the model's attention to what matters, just like humans format documents with headers and subheaders, etc. 3, repeat important information or instructions at both ends. A little bit of redundancy can help. Say it at the beginning, say it again at the end if it's critical. Also, for number 4, you can chunk large documents. Instead of stuffing the 100-page PDF in one prompt or one attachment, break it into logical sections and process them separately. You'll get better results. 5, set explicit token budgets. You can, know your model's effective limit. Often 50 to 75% of the advertised maximum. Kind of design your workflow accordingly, essentially. Number 6, summarize conversation history periodically. Remember, every turn in the conversation is needing to reprocess all of this information, so you can ask it to summarize all the key salient points from the conversation thus far. If you're in a long chat, just ask the model to summarize what's been discussed. Start fresh with that summary. It can reset the context. And just to be clear what I mean by that, you can tell it to summarize all the information contained thus far. It will output that right in the current chat window. Copy that output and then open a new chat window and then go back in and give it that summary from the prior session. That creates the experience of very similar to just continuing in that original thread, but you just opened up a bunch of new context window because it's not reprocessing this long conversational thread. Another tip is to use system prompts strategically. Define the role, the constraints, and the output format up front. That'll help keep the model focused. Also, test at your actual target length. What I mean by that is don't trust the spec sheet. Don't trust the published context window size. Run your use cases with documents at the length you'll actually use and verify performance. Really see, does the quality of the output change so that you can get a sense and start kind of developing a little bit of the art and skill around how to spot when the context windows become an issue, how to manage this, etc. And then the last point I would say is monitor for quality drift. If responses start getting vague, inconsistent, seem off, again, reset the conversation. Long chats degrade. So don't ignore context windows. A lot of the fears, uncertainty, and doubts I actually hear people who've used AI lightly bring up in conversations, a lot of those actually trace back to them not understanding what a context window is and not knowing how to manage it. When you manage this well, you can maintain high quality outputs and a much better experience. Now, that said, I will admit it does not mean there's never issues, there's never hallucinations. So let's talk about the verify framework. So now you understand the problem, let's talk about the solution. So I'm going to give you a simple framework for validating AI outputs. It's called verify. V is for verify source credibility. If the AI cites a study, a stat, a quote, find the source, ask it to give you the source links, follow those links. Don't trust the citation format. Actually search for it. If you can't find it, assume it's fabricated. E is for examine intent and bias. Consider whether the output reflects a particular perspective. Is it balanced? Does it acknowledge limitations? AI models can inherit bias, again, from training data. And feel free to challenge them. So ask the AI model, did you think about this? Have you considered this perspective, etc.? Again, don't just take what it says as 100% the gospel. You can really challenge it to get it to think more critically, and you should think more critically and independently about what it's saying. R is research. Research the supporting evidence. Don't stop at one source. Cross-reference. If an AI tells you a regulation changed, check the actual government website. If it quotes a statistic, find the original report. See if you can find others that validate it. I is for identify emotional impact. Does the output try to persuade rather than inform? AI can generate arguments that sound compelling but aren't really grounded in facts. F is for find missing perspectives. What's not being said? What counter arguments exist but are ignored? AI tends to provide the most common perspective, which may not be the complete picture. Again, this is where you can keep challenging it, keep probing to expand its purview and the case it's making, and maybe offer a more well-rounded perspective. Y is for yield to critical reflection. Pause before acting on AI output. Ask yourself, what if this is wrong? What's the downside? What's the impact? What would I need to verify before I'd stake my reputation on this? So this framework is about building a habit. Every AI output, especially for business decisions, gets a human verification. We call this human in the loop. Even if it's 30 seconds of verification, you might catch a costly error. Of course, how much effort you put into verification should scale to how critical or non-critical the task is. But the key thing to keep in mind is that human in the loop judgment does not go away. We tell our own employees, use AI, but you are still responsible for those outputs that it may put out. You are verifying it. You have institutional knowledge and deep judgment from years of experience in your field. Apply that to AI outputs. You do not blindly trust them. So let me leave you with this. Hallucinations are not a bug. They are not they are a structural characteristic of how large language models work. No update is going to fully fix this problem. No model upgrade is going to eliminate this risk, at least in the near term. The technology is designed for fluent text generation, not 100% factual accuracy. But that doesn't mean you can't use AI effectively. It means you need to use it with your eyes open. You need to understand these concepts. You need to be on the lookout for these things. So your action item for this week is pick one AI output that you would have trusted before, a citation, a statistic, a key claim, and verify it. Just one. Check the source. See if you can find it independently. Start building that muscle. Start getting in these habits. Because the professionals who win with AI aren't the ones who trust it the most. They're the ones who verify it best and who understand how it works, its strengths, its weaknesses, and where it has limitations and how to work around them. So thanks for watching. We look forward to continuing our educational training series. Have a wonderful day.